Chemistry is amongst the largest and well-known fields of science. If you were to ask most people what they think chemistry is like, a stereotypical assumption would be something like a bunch of scientists with white lab coats working with different vials and different chemicals. Perhaps some of them are boiling and changing colors like they show in the movies. People might also associate chemistry with chemical equations and think about how different things will react with one another to form other things. Also perhaps the models of molecules and periodic table of elements, which can be depicted in different ways. All of these things are a big part of chemistry, but what I want to do in this video is appreciate what chemistry is at its very core. Chemistry is one of the sciences that really just help us understand and make models or predictions about our reality. Even with something like the notorious periodic table of elements, which you'll see at the front of pretty much any chemistry classroom, we kind of take it for granted. This is the product of thousands of years of human beings trying to get an understanding of all the different complexity that goes on in the universe. If we look at the universe, we see all these substances that we can definitely tell are different in certain ways. Things like fire and water have different properties and reactions with certain other things. In other planets even, we can see these meteorological patterns, such as hurricanes the size of Earth on Jupiter and the acidic rain of Venus. Even in life, such as cells, and also more complex organisms, we see all of this complexity, and it looks as though there's an infinite spectrum of differentiation out in the environment. In extremely powerful machines such as our brains, we have trillions of neurons that are sending electric signals all the time, with hundreds of thousands of chemical reactions happening every second. So all this information would have been easily overwhelming to discover. And so, how did we make sense of all that goes on in the universe? It was definitely not an easy path, but over thousands of years, we did begin to make sense of all this. So it's very lucky for all of us to be born in the era that we're in now, because now we're able to get a reasonable and understandable answer for so many age-old questions and concepts. What continues to make it interesting, however, is that it's a partial answer, almost every time. Which is beneficial because if we had the full answer, there wouldn't really be any curiosity and drive to learn, because everything would already be known. Now we realize that this periodic table of elements is what explains all of the complexity that we see in the universe, and that everything is made of these basic building blocks, which are atoms, which are like the Lego pieces that make the universe. We're aware that there's roughly 118 types of elements that we have discovered, but there's a few of these elements that disproportionately show up in our environments, such as carbon being the universal building block of life, which will be a future video. Even the elements themselves are made of subatomic particles like protons, neutrons, and electrons, which we learned about in our elements and atoms video. These particles are pretty much just rearranged in different amounts to give us all these different elements that have all this variation in properties. So while the visual stereotypes of chemistry might depict mad scientists hard at work in their laboratories, what it really is at its essence is how to create models that we can understand that explain a lot of the complexity in the universe around us. To put chemistry into context amongst other fields of science, many people would say that at the purest level would come mathematics. We study and observe ideas in mathematics, which can even be independent of anything that you've observed or experienced in reality. If we were to ever encounter another intelligible species, mathematics would probably be the bridge of common understanding, regardless of either one's perception of the world. So on top of math, we would question how exactly our reality is structured, in which case physics would come into play. At the most basic level, what are the constituents of matter? And what are the mathematical properties that describe how they interact together? Then, when you go one level above that, we get the field of science that this video is about, which is chemistry, which is actually very closely bonded with physics and biology. When we'll talk about these chemical equations and molecular structures, the interactions between the atoms are quantum mechanical interactions that we still don't fully understand yet at the highest level. But with chemistry, we're able to make use of math and physics to begin to think of how all the different building blocks can interact to explain many sorts of phenomena. An example of this can be hydrogen and oxygen combustion, which releases a lot of energy. Combustion is commonly associated with fire, but what even is fire at its most basic level? This is why chemistry is so important, and it's actually the precursor to the next level of understanding, which is biology. So when you study any of these fields, there's points at which the fields blend together since they're so reliant on each other, like a tower of Jenga blocks. But the biology in a human being, or any organism in fact, is based on molecular interaction. In a human, over a quintillion chemical and molecular interactions occur in the body every single second. All of these molecular interactions fall into the category of chemistry at the end of the day. And so you can begin to see the reliance that these fields of science have on one another. Not one of these sciences is more important or better than another, as these are all incredibly fascinating fields in their unique ways. As human beings first became thoughtful about their environment, we asked ourselves, why are we here? What is this place? Why do we exist? How do we exist? And chemistry is one of the components that allows us to build these models for us to understand interactions at a scale and at a speed that we can't directly observe. But we can still begin to make predictions. So that's really what makes chemistry interesting. And so when you're studying chemistry, it's better to refrain from viewing it as a chore that the education system is forcing onto you, but more as an opportunity, and a very fortunate opportunity, to get a grasp of knowledge that people 100 years ago would have done anything to gain. To be able to have the access to knowledge and deep understanding that we have today is considered a privilege to be able to learn at this level. And then we have to think about where the future will go, as none of these fields of science that I've talked about are complete or finite fields. Pretty much everything is only partially answered, and there's basically an infinite amount of knowledge that we could learn relative to what we know now. But it's exciting to see that we're now getting such a strong start, and we're beginning to answer the unknown and the ability to describe our reality. So we will continue on this venture through the deep realms of chemistry in the next chemistry video. But for now, I thank you all for watching.